Hello world and welcome. Today we'll talk about RNN and LSTM. This is part 2 of the Bitcoin stock price prediction. My name is Harris and let's get started. So for more tutorials and content, hit the subscribe button or leave a like or comment there. I'll be really happy about it. So what are basically the pros of LSTM? You can basically use this in text and video speech, and especially in time series, to analyze the data afterwards. You can basically update the weights with backpropagation, and you can create dependencies between the data points. Here you can see the difference between neural net and RNN, where on the left side we are using forward propagation to just send the weights from one layer to the next. And on the right side you can see if you rotate anti-clockwise, so vertical state, you have the RNN, which is using the backpropagation itself to update the weights. In the middle you can see a hidden state, which has a connection. If you see the dependencies of the data points here of the football player, you can see basically that if you want to predict what are the next steps, you need to check all the time slices of the time series. That's why we are taking the LSTM to analyze this. Here you can see RNN how it looks inside vertical state. Here you can see the different time slices of the same neuron, where you can see X and Y, and in the middle the hidden state, which will update the weights from one state to another through the time. Here you can see how it looks inside. So on the left side you have only the RNN unit within activation function and output and hidden state. On the right side you can see the LSTM unit. It's just like a memory cell with the forget gate, output gate, etc., where you can basically load data, save data, and you can also delete data. So it's like a memory cell itself. So today we're covering part 2, where we're going to see the Bitcoin stock prices. That's for here I imported all the packages and the libraries itself. I load the data, and this time we have 2 columns actually, which we are going to take like a feature, like input, the open price and the volume. Last time I took the open and the high price itself per day, but if you can see that the open and the highest price are pretty the same, so that's why we're taking also the volume, which is like factor 3 more, and it's a pretty good feature itself to make the model itself a little bit more accurate. Then we are going to scale all the data. We are taking the standardization, the normalization itself, to put all the data between 0 and 1 to make the weight itself a little bit getting better and getting more accurate. And there you can see the open and the volume. It's between the value of 0 and 1. And afterwards we are using like a time frame. We are going back 20 days back to see how the data looked like to predict the next steps. That's why we took the last 20 days here to predict the price. Then I split everything here, training test data, and then applying the model with the LSTM layer here, dense layer, and the output to calculate everything. And then afterwards we evaluate the model, where you can see here the accuracy got a little bit better this time. We are taking the prediction itself, and if you take all the data here, you can basically want to go from the not scaling data back to the inverse, or scale back to original. That's why I applied here the formula of the min-max standardization to scale back to the original, to have the real data itself. And then you can see here from 2015 to now that the open price here. The orange here is the predicted price. It got actually pretty good. If you see only the last 100 days, we can see that there is a kind of time delay itself, but the prediction got better this time. So in the next tutorial, we will cover how we can even adjust more parameters within the neural net to make the LSTM even more accurate to predict the price. So thanks a lot for watching. For more content, hit the subscribe button or leave a like or comment there. Thanks a lot and see you soon.